Hello class, this is Mr. Sutton, and today we are going to be talking about radical expressions with operations. So we're going to be adding, subtracting, multiplying, and dividing radical expressions. We're going to start off with multiplying radical expressions. So here our first question is, what is the product of 9 and 2 radical 90, or 2 square root 90? In simplest radical form. So one thing to note when we're talking about the product of radical expressions is, let's take a look at this 2 root 90 for a second. This right here is already a product of something. It is the same thing as 2 times root 90. And that's something to note. So when I ask you what is the product of this times this, really it's the same thing as 9 times 2 times the square root of 90. So we could think about them all separated like that. So 9 times 2 would be 18. And then we would still have root 90. And then we want to start to think about how can we simplify this root 90. So if I were to do the prime factorization of 90 underneath this square root, it would be 3 times 3 times 5 times 2. So I thought 90 breaks down to 9 times 10. 9 breaks down to 3 times 3. 10 breaks down to 5 times 2. So that's how I came up with that. So then once you have that, you can pull out the things that can be square rooted. So this 3 times 3 can be square rooted. So that would be 18. And then the 3 goes out here. So times 3. And then the 5 times 2 stays underneath the square root. 18 times 3 is 54. And then underneath the square root, 5 times 2 is 10. So once we got to this step here, it was just simplification like we are used to. The new thing is the multiplication beforehand. So the things that are outside of the radical, we multiply as normal. So 9 times 2, we multiply 9 times 2 to get 18. That root 90 stays outside, and we can simplify it that way. So let's look at an example where they both have radicals attached to them. So here we would have 10 root 3 times 9 root 24. And remember, like I said, so like up here I have 2 root 90 is the same as 2 times root 90. So really we want to think about this as 10 times root 3 times 9 times root 24. And the reason we do that, that helps us because we can reorganize this to have the radicals next to each other. So, and the numbers outside the radical next to each other. So 10 times 9, I'm going to put those next to each other, and then times root 3 times root 24. I'm going to move this down here. So 10 times 9 is 90. And then we can move these underneath the same radical. So that would be 3 times 24. And I can multiply these right here. 3 times 24 would be 72. But I don't necessarily want to do that because I want to simplify this radical. So I could say 72, but what I'm going to end up doing anyways is doing the prime factorization like I did up here. So you can multiply these here, but you would just be creating an extra step for yourself because what you want to do is you want to simplify this. So the prime factorization would be 3, and then I want to think about how to prime factorize 24. So that would be 3 times. So the prime factorization of 24 would be 3 times 2 times 2 times 2. So we can start to take out the perfect squares here. So 3 times 3 and 2 times 2, and we'd be left with this 2 left over. So 90 times 3 times 2 square root 2. So what is 90 times 3 times 2? That is 540. We're left with the root 2 left over. So what we want to do is we want to multiply the numbers outside the radicals. We multiply the 10 and the 9 to get 90. And then we want to multiply the numbers inside the radical, the root 3 and root 24. And we want to simplify that all together, 540 root 2. All right, so make sure you have these examples down. And here are some notes for that. So multiply the numbers outside of the radical. So like we did here, we multiplied the 10 and the 9 to get 90. Multiply the radicands. Those are the numbers that are inside the radical. So like we did here, we multiplied the 3 times 24. And then simplify the combined radical. So like we did here, these last steps, we had 90, and then the square root of 3 times 24, we simplified what was underneath the radical to get 540 root 2. So those are your notes for that. Make sure you have those things written down. Next, we're going to talk about dividing radical expressions. So when we're talking about dividing these rational expressions, we want to simplify these. So we want to figure out, is there a root 5 within this that I can simplify? Let's see. So we want to do a factorization of this root 560. So the factorization of 560 is 5 times 2 times 2 times 2 times 2 times 7. And if you're not sure how to do this, start with what you know you can divide 560 by. So since it ends in a 0, I know I can divide it by 10. So that would be 5 times 2. And then you'd be left with 56. And 56, I know that can be factorized into 8 times 7. So that would be 8 can break down to 2 times 2 times 2. 7 is prime, so that cannot be factored anymore. So this is the prime factorization of 560. And what I can do is I can separate these radicals. So what I'm going to do is I'm going to separate the 5, because I'm going to cancel that with the bottom. And then I can also take out these perfect squares. So 2 times 2, 2 times 2, and then just a root 7 out here. So the root 5s can cancel. These would be the square root of 4, right? 2 times 2 is 4. So this would equal 2, and this would equal 2. So I would really have 2 times 2 times the square root of 7. So that would be 4 root 7. That's my answer for that one. Let's go ahead and take a look at this bottom one. We want to do the same thing. We want to factorize what we have in the top and see if we could simplify with anything in the bottom. So 72, I know that can be divided into, or factored into 9 times 8. So the 9 would be 3 times 3. And the 8 would be 2 times 2 times 2. So the prime factorization is 3 times 3 times 2 times 2 times 2. Now, I went ahead and also factorized this 8 in the bottom because it looks like I'm going to have some 2's that cancel. So I factorize the 8 to 2 times 2 times 2. Now I want to go ahead and separate this radical out. So I have square root of 3 times 3, square root of 2 times 2, and the square root of 2 left over, and then 2 times 2 times 2 on the bottom. So square root of 3 times 3 is 3. The square root of 2 times 2 is 2. So really I have 3 times 2 times root 2 over 2 times 2 times 2. So I can cancel these 2's. I cannot cancel this root 2 with any of these because that is not the same number. Root 2 is an irrational number. Root 2 is like 1.41421, etc., etc., etc. So that is not the same thing as 2 and cannot be simplified. So really I have 3 times root 2 on the top and 2 times 2 on the bottom. So my most simplified answer is 3 root 2 over 4. So here are some notes you can say over dividing radical expressions. Please write these in your notes. So first step, expand or find the prime factorization of the numerator and denominator if possible. Simplify any common factors on the numerator and the denominator. So for example, like after we expanded here, we found that these 2's were common factors, or up here, after we expanded, we found that the root 5 were common factors, so we simplified those. And then you multiply the remaining factors on the numerator and the remaining factors on the denominator. So make sure you have those notes written down. Now I want to talk about adding radical expressions. So we have these radical expressions that we're going to add, express in simplest radical form. So the rule for adding radical expressions, and this is also the rule for subtracting, is that the radicand must be exactly the same. So the number underneath the radical, here we have 147, and here we have 48. They must be exactly the same in order to add them. It's kind of like combining like terms, kind of like the situation up here. So like 4x squared plus 2y squared. We cannot add these because they're not the same like term, but 4x squared plus 2x squared, we can add this. These are like terms. We have 6x squared. So it's kind of like that. So right now, these are not the same, but both of these can be simplified. So maybe we can simplify these radicands into something that is the same that we can add. So let's go ahead and expand the radicands, do the prime factorization, see if we can simplify these. So here is the prime factorization of 147, 7 times 7 times 3. Here's the prime factorization of 48, 2 times 2 times 2 times 2 times 3. So we want to see, we want to look for things we can pull out. So we can pull out 7s, these 2's, and these 2's. So we'd have 3 times 7 times the square root of 3 plus 6 times 2 times 2 times the square root of 3. Notice now that we have the same radicand, we have root 3. So now these are things we can add together. First, we want to multiply this business out in front of the radical. So negative 3 times 7 is negative 21. Root 3 plus 6 times 2 times 2 would be 24. Root 3. So, and then now all we have to do is add the numbers out in front of the radical. So negative 21 plus 24, that would give you a positive 3, and then the root 3 just stays on the end. Similar to how we did in the combined like terms, we just add the numbers out in front, and the root 3 stays on the side. So we want to go ahead and do the same thing for this next example. We want to expand the radicand, see if we can simplify it into such a way that the radicals are the same so that we can add them together. So 10 can be expanded to 2 times 5. Nothing we can pull out of the radical there. 40 we can expand to 2 times 2 times 2 times 5. So we can pull out this pair of 2's. So we would be left with, so negative 6 root 10. I'm just going to multiply these because there's nothing I can take out there. Then we'd have 8 times 2. I'm going to pull out those 2's. And I'm left with 2 times 5 again, so that gives me 10. So notice once again we have the same radicand, which is good. That means we're going to be able to add these together. First I need to multiply this 8 times 2. Always follow your order of operations. So negative 6 root 10 plus 8 times 2 is 16. Root 10. So negative 6 plus 16 give me a 10, and I just include the root 10 there on the end. So the answer is 10 root 10. All right, make sure you have this example down. So now we're going to talk about subtracting radical expressions. Same rule applies here. You have to make sure the radicand is exactly the same. The only difference is we have to be careful with our negative sign. So I'm going to go ahead and expand this 150 and this 96 to see if I can simplify these radicals into something that we actually can subtract. So this 150 breaks down to 3 times 5 times 2 times 5. So I can pull out these 5's, And this 96 breaks down to 2 times 2 times 2 times 2 times 2 times 3. So I can pull out 2 pairs of 2's. So I'm going to go ahead and do that. So we have 9. I'm going to pull out the 5. And I'm left with 3 times 2 minus 10 times, I'm going to pull out 1 pair of 2's and then the other pair of 2's. And I'm left with 2 times 3. So it looks like we will have the same radicand, that 2 times 3 or 3 times 2, which would be 6. So 9 times 5 is 45 root 6. And then minus 10 times 2 times 2 would be 40 root 6. 45 minus 40 is 5. And I want to keep that root 6. All right. All right, now let's check out the next one. Here we have 4 root 96. This one should be easy to simplify because we just did it up here. And then minus 6 root 24. So I'm going to go ahead and expand these and see if I can simplify these radicals into something that I can actually subtract. All right, so 96 breaks down to 2 times 2 times 2 times 2 times 2 times 3, like we did up here. And 24 breaks down to 2 times 3 times 2 times 2. Figured that out so 24 I broke down to 6 times 4. 6 breaks down to 2 times 3. 4 breaks down to 2 times 2. So that's how I did that. So we want to think about which pairs we could pull out. Once again, pair of 2's, pair of 2's. And then over here we just have 1 pair of 2's we could pull out. So this will equal 4 times 2 times another 2. We're left with 2 times 3 left over. Minus 6 times just the 2. We're left with 2 times 3 left over. We want to make sure we multiply these numbers out in front before we subtract them. So 4 times 2 times 2. 4 times 2 would be 8, times another 2 would be 16. Root, and then 2 times 3 is 6. Minus 6 times 2 would give me 12. Root 2 times 3 is 6. So 16 minus 12 would give me 4, and I want a root 6 here on the end. Make sure you have both of these examples down, and I just have a little bit of notes here at the end. So the rule for adding and subtracting radicals is you can only add or subtract if the radicand is exactly the same. So some steps. First, you want to simplify so that the radicand is the same if possible. Then you would add or subtract the numbers in front of the radical. That is all I have for notes for today. If you have questions about anything, make sure you ask your teacher for help or come to office hours. Have a good day.